Alrighty, so in this video, we're going to talk about question number 3 from page number 4 on exam number 4, which talked about antiderivatives and finding area under the graph. So for this question, suppose that integral 2 to 5 f of x dx equals negative 16. We also know that g of x is an even function, and integral of negative 2 to 0 g of x dx equals negative 6, and integral of 0 to 5 g of x dx equals 10. So given that information, find the integral 2 to 5 of 1 over 4 times f of x minus 3 times g of x dx. So how do we approach this problem? So we already have a couple givens here. So we have this given, we have this given, and we have this given. But one more crucial information that we're also given is that g of x is an even function. So what does that mean specifically? So when it comes to finding the area under the curve, when you have an even function, so for example, we have the integral of negative 2 to 0. So given that this g of x has an even function, its opposite of integral 0 to 2 would equal the same in this case. So that means that integral of 0 to 2 g of x would equal negative 6 also, because both are even in this case. So what are we going to do with that information? So we want to find f of 2 g of x, because we do not have that given. We only have integral 2 to 5 f of x dx given, but we want to find integral 2 to 5 of g of x in this case. So how do we find that? So given that we have the information here, so we want to set this integral in such a way that enables us to solve for this specific term right here. So how do we do it? So we would set this up as integral 0 to 5 g of x equals integral of 0 to 2 g of x plus the integral of 2 to 5 g of x. So why set it up like this? So we set it up like this because we have specific intervals given in this case. So right here we have integral 0 to 5 g of x, and we also have given that we gotta find interval 2 to 5. So what intervals must exist between 0 to 5 in order to find 5 to 2? There must be 0 to 2, because we already have the integral of negative 2 to 0 g of x given, and given that g of x is an even function, we already have the integral of 0 to 2 g of x given, which equals negative 6. So in this case, we just substitute the values that we have given. So the integral of 0 to 5 g of x equals 10, and then substituting the integral of 0 to 2 g of x, it would just be negative 6, plus integral 2 to 5 g of x. So now we just solve for this. So we'll just solve for this algebraically. So we add 6 to both sides, just like that. We have 16 equals integral of 2 to 5 g of x dx. We can just say it like that if we wanted to. So given that we found this information, we can use this to substitute it into this function, into this term right here, and then we can use this information to substitute it into this term right here, into the f of x. So what's next? We want to use what we have and just substitute those in. So in this case, given that this integral applies to both terms, right over here, we want to rewrite it as integral 2 to 5 times 1 to the 4 f of x minus integral of 2 to the 5 free g of x. So now we just substitute those in. So this right here equals negative 16. So we just do 1 over 4 times negative 16 minus 3 times 16 in this case. So what do we have? So 1/4 of negative 16, that just results in negative 4. And now over here we have minus 48. So yeah, these two terms right here, so that just equals negative 52. So negative 52 in this case equals this expression right here. So we can just write it out to as a way to express it firmly. So you can write integral 2 to 5 of 1/4 f of x minus free g of x equals negative 52. So this should be the final answer for this problem.